This is a CCEA mathematics paper. It's from January 2020 and it's M8, paper 2. So it's a calculator paper. So let's take a look at question 1. The equation x cubed plus 3x equals 25 has a solution between 2 and 3. Use a trial improvement method to find this solution. Give your answer correct to one decimal place. You must show all your work in. So it has a solution between 2 and 3. The most obvious place to start is halfway. So if we start then at 2.5, and what we do is we substitute in 2.5 then into this equation here. So we want to do 2.5 cubed plus 3 times 2.5. 2.5 cubed plus 3 times 2.5. And that gives me 23.125. That's too small because it's supposed to be 25. So go to the next one then, 2.6. It's 2.6 cubed. Oh, there I've typed it in wrong, sorry. 2.6 cubed. Going badly. 2.6 cubed equals plus 3 times 2.6. I get 25.376. And that then's too big. So the answer will be one of these two. I suspect it'll be this one because it's way closer to 25, but we just need to make sure by going halfway in between. So we do 2.55. So 2.55 cubed plus 3 times 2.55. I think that's gone in wrong again. 2.55 to the power 3 equals plus 3 times 2.55 equals 24.23. Yes, so that's 24.231375, and obviously that's too small. So 2.6 then is our closer one, and that's where we put our answer in down here. Sorry about the bad calculator work there. Number 2, the first 4 terms of the sequence are 2, 7, 12 and 17. Write down an expression for the nth term of the sequence. So we number them 1, 2, 3 and 4. Our gap then for each one is going to be 5. That means it has to be 5n plus or minus something. I substitute the number 1 into this here. 5 times 1 gives me 5, but I want 2, so it's going to be then 5n minus 3. Always good to check, so try it with one of the numbers. Let's try it maybe for the number 3. 5 times 3 is 15, take away 3 is 12, so it does seem to work. PQRS is a rectangle. Shade the region inside the rectangle which is more than 5 centimeters from P and more than 3 centimeters from the line QR. So we need to get our compass for the 5 centimeter bit. So I have my compass ready here and I want to set it up then for 5 centimeters. So I put the pointy bit here at 5, and then I'm going to set my compass in to 5 centimeters. Hopefully you can kind of see that. And I then mark off, put the point at P, and then mark off my 5 centimeters in here. So more than 5 centimeters from P then is anything outside this circular bit. It also has to be more than 3 centimeters from the line QR. So that's going to be this line here, about 3 centimeters out. So let's just measure that. So I've set that to 3. Hope that makes sense. Mark a wee bit there. Mark there. And then join my lines up. So where are we looking for? More than 5 centimeters from P, this, and more than 3 centimeters from QR is this. So the bit we want is that there. Question 4. A survey is carried out to find out the number of electric cars on the road. 100 cars are surveyed each day for 4 days. Results are recorded in the following table along with the relative frequencies so far. So on day 1, 100 cars surveyed, and there were 11 electric cars, so 11 over 100, 0.11. On day 2, it was 12, so it's not 12 over 100, it's 11 plus 12 then over the 200, so it gives you a more accurate figure. So that's 23 over 200, gives you 0.1155. Then 11 plus 12 plus 16, so that's 39 over 300. The 300 days gives you 0.13. And then the next one's going to be 11 plus 12 plus 16 plus 9 over 400. So that's 48 over 400. So if we do our 48 over 400, of course we get 0.12. Work out the missing relative frequency and record it in the table. That's 0.12. What would be the best estimate for the probability that a car chosen at random is electric? It's obviously this one here. So we would have then 0.12. There are 15,000 cars on the road. How many would you expect to be electric? So we would do 15,000 multiplied by 0.12, and that gives us then 1,800. Question 5. Write the following in standard form. So first of all, with 0.0000385, so we want to put our decimal point in here, so it's going to be 3.85 times 10, and then count 1, 2, 3, 4, 5, 6. So it's 10 to the minus 6, minus obviously because it's a small number and it's going that way. This here is sort of a confusing one. I'm going to use the eraser here to kind of cover up this, and I'm just going to write 167 in standard form. So 167 is 1.67 times 10 to the power of 2, and then multiplied by 10 to the power of minus 9. If we multiply these two, we add the powers, so it's going to be 1.67 times 10 to the minus 7. Question 6. A sketch above shows part of the graph of the quadratic function y equals minus x squared plus 4x minus 3. Write down the coordinates at the point where the graph will cross the y-axis. So it crosses the y-axis whenever x equals 0. So y is minus 0 squared plus 4 times 0 minus 3. So it's obviously then just going to be minus 3. So my coordinates then are 0, minus 3. Work out the coordinates of the highest point on the graph. The highest point in the graph, so this is a parabola, which means it's symmetrical, so the highest part is going to be halfway between here, so it's whenever x equals 2. So y equals minus 2 squared plus 4 upon 2 minus 3. Y is minus 4 plus 8 minus 3. So it's going to be 1, so it's going to be the point then 2, 1. Question 7. A model of a building site is to be made. The length of the building is 100 times the length of the model. How many times larger is the area of the building? So the lengths are in the ratio 1 to 100. So that means the areas are going to be in the ratio 1 squared to 100 squared, which is 1 to 10,000. So the answer then would be 10,000 times bigger. Simplify the following expressions. So we're just going to take each wee term separately here. First of all, the number terms is going to be 12. And then the x terms, we have x to the power of 5 and we have x to the power of 2. So we add those two powers, we get x to the power of 7. And then we have y to the power of 3 and y to the power of 2. So adding those, y to the power of 5. Part B, we just need to cube everything here. So the 2 cubed gives me 8. P cubed, it's obviously p cubed. Q squared cubed, we multiply then those two powers. So it's going to be q to the power of 6. The probability that Jack takes a packed lunch to school on any given day is 3/8. Complete the tree diagram to show this information for the 2 days. So we'll have lunch and no lunch, lunch and no lunch, lunch and no lunch. Probability of lunch is 3/8, which means this is 5/8. 3/8, 5/8, 3/8, and 5/8. What is the probability that Jack takes a packed lunch to school on only one of the 2 days? So that would be one option there, and that would be one option there. So we got to get those two. So we times along the lines. So 3/8 times 5/8, top times top is 15. 8 times 8 is 64. It's going to be the same for this one. 5 times 3 is 15. 8 times 8 then is 64. So our sums then are going to be 15 over 64 plus 15 over 64, because both those options work for us. That gives us 30 over 64, and that cancels down into 15 over 32. There are 2 types of ticket available for a concert, seated and standing. Julie buys 3 seated tickets and 1 standing ticket for £82. Gemma buys 5 seated tickets and 4 standing tickets for £174. Work out the cost of each type of ticket. Solution by trial and improvement will not be accepted. That means you can't guess answers and see if they work. So we're going to use simultaneous equations. I'm going to call the seated ones to be x and the standing ones to be y. So that's x and that's y. So we're going to have 3x plus y is 82, and then 5x plus 4y is 174. I'm going to use the elimination method, so I want to make either the x's or the y's the same as each other. So I'm going to times this one here by 4. So equation 1 times by 4 gives me 12x plus 4y equals 328. And then because my y's are now the same, I'm going to subtract, but I hope this doesn't confuse you. I'm going to do this one, take away this one. So 12x take away 5x gives me 7x. 4y take away 4y disappears, that's what we wanted. And that then subtract those, I get 154. That means x is 22. I then want to substitute this into number 1. So number 1 is 3x plus y is 82. If x is 22, then 66 plus y is 82, and that means y then is 16. So the seated ones are 22, and the standing ones then are 16. Diagram not drawn accurately. We have this and this. Calculate the area of the triangle BCD. So we have BCD, so it's the area of this one here that I want, and we're hopefully going to use the formula a half AB sine C. Again, it's in your on your formula sheet on the first page. I'll show you in just a wee second. So we have the angle, we have this side, and we need to use something to work out this side here. Now don't be fooled, this isn't a right angle triangle, annoyingly, otherwise it would be nice and straightforward. So we're going to have to use then the cosine rule here to work out this one here. So whatever way you use your cosine rule, if you want to go for that, or kind of BD, so BD is the length that we want. So I know then that this squared is the other 2 squared, 12 squared plus 14 squared. Take away 2 times 12 times 14 cos 62. BD squared then is 144 plus 196 cos 62 equals times 2 times 12 times 14 is equal to, that's 157.742. So I do 144 and 196, take away that. I think it gives me 182.257. And then my BD, I want to take the square root of that. I get 13.5. Then I know this information here, so that's my 13.5. So I'm going to then use a half AB sine C. So it's a half times 13.5 times 13. Do you see that there? So it's a half times 13.5 times 13 sine 23. And you put that into your calculator and we get 34.29. So 34.29 then is the area of the triangle that they owned. That's written wrong. 34.29. Apologies. 34.29. Okay. Question 12. ABCDEF is a triangular prism with ABCD a horizontal rectangle and CDEF a vertical rectangle. So CDEF is a vertical. That means this here is a right angle, so that's going to help us. AB is 20. BC is 28 and CF is 14. Calculate the difference in the sizes of the angles of elevation EAD and EBD. So EAD is obviously then going to be the same then as this one here. So if I lift out this triangle here, work out this angle here first of all. That's 28, that's 14, and it's this angle here that we want. Sorry, you can see it there now. Label my sides, that's O, and that's A, and I'm wanting this angle here, so I'm going to use tan. So tan X is 14 over 28, X then is tan to the minus 1, 14 over 28, and that gives me 26.56505. So I then need to get a few different dimensions. If that's 28 and that's 20 and it's a rectangle, if I use Pythagoras, I can find that distance then BD. So again, let's take this wee bit out, the bit that we need. So that's 20 and that's 28 and that then is BD. So BD squared is equal to 20 squared plus 28 squared. So BD square root of 20 squared, 28 squared, and that equals 34.4093. And I now have this right angle triangle here. So that's 34.4093. That is 14. And if I lift that out, it's just going to be a right angle triangle. I'm going to use tan again. $34.4093. And then that's going to be 14. So tan X is 14 over 34.4093. X is tan to the minus 1. 14 over 34.4093. And that angle then is 22.13977. Notice I've kept kind of lots of decimal places there in my working out, so we can do that. So then the difference is equal to 26.56505 take away 22.13977, and then give this answer to 2 decimal places is going to be 4.43. So a fair bit of working out for that bit. Finally then, almost finally, sort of one after this. 2 vases are of similar shape. The surface area of the small one is 16/25 of the surface area of the larger one. The small vase has a volume of 320. Calculate the volume of the larger vase. Okay, so the ratio of areas is 16/25. That means then ratio of lengths is the square root of that, so that's going to be 4/5. That means then the ratio of volumes is going to be this cubed over this cubed, so it's going to be 64/125. So to find the volume of the big one, I want to times by 125 and divide by 64. If you want it 64/125, and I have 320, and then you kind of times that, so whatever way you want to do it, you realise that that's times by 5, and times that by 5, or just what I said, times by 125, that by 64, you end up then with 625. So the answer is 625 mils. Y varies inversely as x. When x is 12, y is 10. Find the values of x when y equals x plus 7. So y inversely as x, so it's going to be k over x. We know when x is 12, y is 10, so 10 equals k over 12. So that means times both sides by 12 that k is 120. So y is 120 over x. Find the values of x when y equals x plus 7. Well, y is 120 over x. So 120 over x is x plus 7. We put times through here by x. 120 x. So if times this by x, that gives us 120. The x disappears. Times this by x, I get x squared. Times this by x plus 7x. And we can see now we have a quadratic equation. So I take everything to the one side. X squared plus 7x minus 120 equals 0. I hope your factors of 120 are good. This one factorizes. We're looking for two numbers that multiply to give minus 120, and they add to give 7. So because one's a minus, one's going to be a minus, one's going to be a plus, and factors then that multiply then to give 120. So 15 and 8 are going to work. So x plus 15, and then x minus 8. So the two numbers then are going to work is x is minus 15, or x is 8. So just stick that in where the answers are there. X is minus 15, or x equals 8.